Welcome to Programming with Python session 17. In this session, we are going to primarily focus on exceptional handling feature of Python. Before I move ahead with the content of today, I would like to introduce our website technolearnit.com is what you see here, and I would recommend you to go through each and every tab of this website. And if you want to contact us, here are the different contact numbers and different means of contacting us. So please use any one of them if you wish. Similarly, the resources used for all the sessions, all the online sessions so far have been made available here on this website under resources tab. So I would strongly encourage you guys to download these resources and make use of them to the maximum extent. Also, the same page will have the details about the next live session. Hence, you can just keep an eye on this page and get up to date information on the next live sessions that we are going to conduct and so on and so forth. All right. With that said, I would also like you to introduce to our YouTube channel technolearnit.com. I would strongly encourage you to subscribe to this channel, and once you subscribe, you'll be getting all the notifications, including our daily quizzes that we post. Okay, so these quizzes are less than half minute shots, so you can just guess the answer and wait to watch this quiz till end, so that you will understand the right answer, because the right answer will be highlighted by the end of the play, and you can compare your guess with the right answer. Okay, and this allows you to be in touch with the concepts, and if you are planning to attend any written interviews or so, these questions will really help you out. All right, with that said, let's go back and let's continue our topic of day. We are going to cover these topics today. So what is an exception, why exception handling is really required, right? And what is the difference between exception and the syntax errors in a program, right? And what are the common exceptions that are available in Python? Try and catch blocks. Okay, here when I say catch, it is nothing but except basically. And how to handle specific kind of exceptions in Python. And how can you also use multiple exception blocks in the same piece of code. Okay. Similarly, how can we have multiple exception blocks and handled by single exception block. Okay. And what are the else blocks and finally blocks in relation to the exceptions. Nested try blocks. Okay, and how can you raise your own exceptions in Python code? And how can you create your own user defined exceptions and raise them whenever required? Also, how to capture the exception object. Okay, so these are the topics that we are going to discuss in detail. So for for all of these topics, we have the details recorded in these resources. So by the end of this session, you will be having these resources available for you on the same website that I have shown you, so that you can download them and make use of it. All right. So now, before I get on to further details, I would like to just show you some practical problems that we face when we are dealing with the programming part of Python. Say, for example, you want to read the age of the person. For that, what will you do? You may probably take some variable age, and you may ask user to enter the age. For example, enter your age. Yeah, enter your age. Soon after you press enter on IDLE, it will just wait for user input. So I just type in 22. Okay, and thereon you can make use of that variable age, and you can find out what the value is present in that, and so on and so forth. All right. Now, what if I'm just going to execute this one more time, the same statement. This time, when it asks me to enter my age, I'll just enter some string. That is where the problem arises. You see here, you get something called a value error. What is this value error? Basically, this shows you that you got some value error in your piece of code. So if as long as user provides the right input, that means an integer, the program works well. But accidentally or unfortunately, if the user enters some bad data, when I say bad data, here the expectation is to get an integer from the user while user has entered a string. That means user has entered a different type of data. While I'm expecting an integer, the input that has come to me is string. So while Python is trying to convert this string into integer, it faces problem because it cannot convert this kind of string into integer. However, it can convert a numeric string. For example, you can convert this is also string, right now 123 is also string. However, you can convert it easily into an integer and you can do any integer arithmetic on that. Make sense? Okay. Now the problem is when Python program or a Python script has asked user to enter the input, which is age, user has entered a string, which is not a numeric string in the first place, right? Hence, Python was not able to convert it to an integer and store it in the variable named age. This is a problem. Hence, you see an error called value error. This is what reported by Python, right? This is what reported by Python. Okay. Now, this is nothing but an exception. Though we call it as an error, this is an exception. In fact, this is an exception raised by, we use the term raised. Exceptions are raised. Exceptions are raised. So this exception was raised by the code that you have written, and when Python executes your code, this exception was raised. All right. So what is an exception now? So the basic exception is just an event that occurs at runtime. As you can see, while writing the code, while developing the code, there is nothing. But when you run the program, you got this error. So exceptions are related to runtime. Okay. So exceptions always can happen at runtime of the program that you write. Okay, that you have written. Exceptions are runtime events, right? And what happens really when an exception occurs, right? To understand that, I will go to file mode and I'll show you some code over there. Let us type in some code and we'll understand what happens. Okay, okay, this is all. I'll close this otherwise and I'll create a new file. Okay, I'll create a new file. Okay, so in this case, if you just look at it, right, I'm going to write some set of statements. Set of statements are, let us take the same example of reading the age in, as input. Yeah, you read the age and say, for example, before that, I'll also write one more statement for you to understand the flow of execution. First statement, then it reads the input, and here it should print the age is age, and I just write one more statement here. Last statement, right? Let me save this. Now run this. All right. The statement, first statement has been printed. Yeah, you see here. When you execute this piece of code, the very first statement, the very first print statement gets executed. Hence, you see first statement on the output. Then enter the age. That is what the prompt, because that's the input statement. It is waiting for you to enter the input. I enter 13. Once I enter 13, it has been successfully typecasted as integer, because everything that I pass as input to input function in Python is string by default it is a string, and that string, which is 13, has been converted into an integer. Since it is a numeric string, it can convert it into an integer safely. So now age is a variable which has an integer value 13, and when you move to the next statement to be executed, it prints the age is 13. Finally, the last statement is also printed here. That means all the statements within this program have been executed successfully. I have four statements in my program. All the four statements got executed successfully, right? I'm going to run this program one more time. This time, I'll just give some invalid input. I know that the age has to be an integer, but I just have given some wrong input, different type of input. What happened now? Look at it. If you compare the previous output with the current output, the first statement has been executed. Then the second statement to read the age, the prompt also has been displayed. After that, once the user has entered the input, what happened? An error. What we call it as an error, but it's an exception. An exception was raised, and once the exception rises, if you don't write code properly, in the sense if you don't handle that properly, all the rest of the statements will not be executed. That means once an exception happens, by default, the program terminates there and there itself. Makes sense? The program terminates there and there itself, and it doesn't continue with executing the rest of the statements in your program. So now in this context, if you redefine what an exception is an event that occurs at runtime, and it also interrupts the normal flow of execution and brings the program to termination, right? So this is what happens when you come across an exception in your piece of code, right? And here I have shown you an exception, which is a value error exception, right? You got a value error exception. Let's close this. You got a value error exception. Okay? And there are different types of errors that you can get, or exceptions can happen. You may print some 5 by 0. So now let us run this program. Enter the age. This time I give proper input integer, so numeric, this one only numeric, numeric string only I have given, so it was able to convert into an integer. But look, now the statement, this is failing, and you got a different exception or an error. Generally we call this as an error, but this is an exception really. This is zero division error. So this is a different exception than the earlier. So there are different types of exceptions that are available in Python. So I just very clearly see this division by zero is what it indicates. In the earlier example, it says that invalid literal for integer with base 10. What it means is I cannot convert this string ASD into a decimal number system, okay, into an integer which is a decimal number system, is what it says, right? Which makes sense. What does ASD really mean? It doesn't really mean anything for numerics. Hence, this is unable to convert it to an integer. All right. Next. So you have different types of exceptions, and when exception happens, what happens? The rest of the code that is available in your script or the program won't get executed. So it just an exception brings the program execution to halt. It just terminates the program execution there and there itself, and it doesn't allow the rest of the statements to be executed. This is the nature of an exception, right? This is what happens when you come across exception during runtime. Exception is relative runtime only, not development. Okay, but at a development time, during development process, you need to take care of possible exceptions and into handle them. How to handle exceptions then is what we are going to discuss in detail in this session. All right. Before I jump on to the different types of exceptions and how to handle them, I want to clarify one thing. What is the difference between exception and syntax error? All right. So, for example, I missed or I forgot or intentionally I did not close this single quote. String termination symbol I have missed in my statement. And I attempt to run this program. I'm trying to run this program. So you see here, this is syntax error. This is syntax error. Unterminated string literal. Unterminated string literal. Literal means constant. String literal means string constant. Of course, this is a string constant. But unterminated, what it indicates is you have open symbol for this string, but you don't have the closing symbol. And that's what I'm going to address that error, and probably I will make another mistake here intentionally. And let us run this now. You see here also you will get unterminated string literal on line number 2. So these are all syntax errors. If you look at it again, you will clearly see that it is a syntax error. Okay, this is syntax error. And now go back to your output and check what happened. Was there any output produced? Because right now, where is your error? The error is in the second statement. But did the first statement execute by then? Not really. If you go and check, you will understand that no statement got executed. If the first statement got executed, you would have already seen first statement printed over here, but that did not happen. So first thing, when your program has syntax error, your program event won't start its execution. Yes or no? You may write 1,000 lines of code, but there is just one mistake in maybe last statement, last line of your code. Still, your program cannot be executed. So one syntax error can eliminate the possibility of executing your program. Your program can't be executed when you have syntax error. Make sense? So that is a key difference between exception and syntax error. Exceptions are mostly associated with logical errors, meaning divide by zero. Yes, divide by zero is something that is not defined, but in your program, you have written a statement, right? That doesn't that is not considered as a syntax error. That is considered as an exception. It's logical problem. So all these logical problems will be coming into light only when you start executing your program at runtime, right? Syntax errors before even program starts its execution. Python checks whether each and every statement is as per the expectation from Python rules point of view or the semantic point of view. So if there is any deviation, Python will immediately throw it as a syntax error. Python throws it as a syntax error. Okay, so that is about syntax error. And when it comes to exception, if your program has some code that is possibly exposed to an exception, still your program can be executed. While your program has a syntax error, your program cannot be executed at all. Even you cannot start the execution of the program when you have a syntax error in your piece of code. That is a difference between a syntax error and exception. Exceptions happen at runtime. Syntax errors can be available in your code before the execution. But if the program execution starts, that means there are no syntax errors in your program. That is what you can inform. That is a one difference. That is one difference between syntax error and exception. Make sense? All right. Now, what are some common exceptions? Okay. And I've already shown you. I just type in non-suitable data when in any prompt or in any case where the data cannot be converted into some other data type. It is incompatible data. You cannot just convert a non-numeric string into an integer. Hence, you see value error. So value error is one type of exception possible in Python. Zero division error is another possible exception in Python. Make sense? Zero division error is another possible error or possible exception is what we say. And there are different types of exceptions. Again, what I will do is I'll just show you what type of exception. Indent, oh, sorry, not indent, but comment. Hmm. Oh, sorry. All right. Now, say I have a list. Okay, we call it as my list and have some numbers. Now, if I want to print the very first element in this my list, I would go for 0th index, right? Well, this works well. This should give me 1 because in 0th index 1 is available and that's what you see there. What if I ask for -1? As you know, Python allows negative indexing on lists. So -1, -2, -3 indices. So at -1 index, you have 3. So you should get 3 when you execute this program. No problem. You'll get 3, no problem. Now, what if I ask also what is the least index possible, least negative index available possible now on this? -1, -2, -3. But what if I ask for -4 or beyond that, lesser than that? You get something called index error. You get index error, zero division error, value error, index error. These are different types of exceptions in Python. Okay. Even if you want to go with the positive also, you can just go with positive also because this is 0, 1, 2. three, anything three or beyond three will should give you an integer index error. Yes, you see, this is also an index error, right? All right. Next thing, one more type of exception. Let us have a quick look at it, right? How do you deal with the dictionary? I may have one dictionary. How do you create dictionary using flower brackets? And then I will have key value pairs, right? Name, name is Ramesh. Age is 25. I have two key value pairs in this dictionary. And what if I have to print? How can I print the name of the person here? Student. And here I mention name, right? You can directly ask for name. Okay. So, okay, sorry. This is, yeah. You see here what happened when I say name. Name is undefined. What is meant by not defined? What is meant by not defined? This is name error, value error, index error, okay, name error, divide by zero error, right? What is name error? Here, this name, whatever I have used here, it doesn't know about it. So what I'm going to do, I'll just put in single quotes. You see, you get Ramesh. So name error is something that when it doesn't know what, okay, accidentally the variable and error name has been matched here. But what I can show you is I can just give you something like age. Age is a key here, right? But it was a string. But when I directly use age like this will also give you that same name error. Yeah, see, name error. Age is not defined. I don't know what it is what it says. Correct. So if I just change this to a string type, because here the key is a string type, then this would give you 25. I am asking the value of the key age in student dictionary. So it should give me 25, correct? Here no issues. Now, what if I ask for something that is not available in this key, in these keys? Name is a key, age is a key. Maybe I will ask for class. Okay. Is there any key by name class? Not really. If there is no any key by name class, what happens if I run this? You see key error. This is a different type of exception. So, you know what a value error is, you know what is division error is, you know what is value error, you know what is key error. These are all different types of exceptions only. We see them as errors, but those are all exceptions. Those are all different types of exceptions. These are all exceptions. These are all different types of exceptions. Okay, let me go back to this piece of code again. Even let me go to IDLE, and here what I will do, I will just ask for what is the value of y. You see, this is a different error. This is name error again. Why? Because within the scope of this entire shell or the session, there is no any variable by name y, right? There is no any variable by name y. So it gives you an error, name error. It doesn't know what name is. It's like similar in the case of dictionary that you tried. I don't know what this is. I don't know what age is it said. I don't know what name is it said. Okay. Similarly, when you when you are referring to some variable which is not within the scope of this shell or the session, then you will be getting name error. So these are all different types of errors. Okay. And the other example I would like to really give you is one more example I would like to give, like how many types or what are the different types of exceptions. These are all exceptions basically. Um, I would like to open a file by name my friends.txt. I'm planning to open a file my friends.txt in read as name. Okay, this is a syntax, right? And here I'll just print the content of it. Data dot read. All right, data dot read. And since I have opened the file with open with using keyword with, I need not worry about closing that file and also releasing the resources. It should be automatically taken care. Well, now let me run this. And I'm pretty sure that I don't have any file by name my friends.txt in the current directory where this file is running, where this file is created. I'm going to run this. File not found error. This is another exception, right? These are all exceptions only, different types of exceptions. File not found error is what it says. So this file not found error or the exception is raised when your Python code is trying to refer to a file which is not present on the disk or on the path. So this is another type of exception that Python can raise. So what are different types of exceptions we have discussed so far? Let me go back to this and let me write down what all we have been discussing so far. Okay, what is an exception? I have explained. What is an exception? It's an event that occurs at runtime and diverts the normal flow of execution. Right? If not handled properly, it results into program termination abruptly. Okay. When I say abruptly, it just ends the program execution, even though there are some more statements in our program to execute. Make sense? That's what. When exceptions are generated in your code, if there are some lines of code to be executed further after that line from where the exception has been raised, those statements won't get executed. So this is what an exception is, right? This is what we have discussed. What is an exception, right? It's an event that that occurs at runtime and it diverts the normal flow of what is the normal flow of execution? If you use sequential flow, one statement of the other from top to bottom would be executed, right? If you are using conditional statements, either if block or else block or based on a condition, only some piece of code or the one block will be executed, right? But when an exception occurs, completely The normal execution should be deviated and your program may terminate abruptly. That's what we have discussed, right? And then we also discussed the difference between exception and syntax error. The differences between exception and syntax error. What are the differences? When your piece of code has syntax errors, the program even doesn't start, cannot start its execution. Okay, when it is possible for an exception to occur in your piece of code, you can still execute your program to some extent. That's one difference. The second difference is exceptions are related to runtime and syntax errors are related to development time. While developing, you may make syntax errors or syntax mistakes in syntax, right? So syntax are more related to development time, and exceptions are related to runtime. Those are the differences primarily. Okay. Next, what are different types of exceptions? Types of exceptions. Okay. We have discussed what type of exceptions we have discussed. We have discussed zero division, error exception. When can this happen? Zero division error exception. It can happen whenever your piece of code is attempting to perform division by zero in any arithmetic operation, right? And we also have seen value error exception. Value error exception, as I have shown you, can occur in multiple places. For example, if you are referring to a variable that is not within the scope from where you are accessing it, that results into value error, right? And then name error. Okay? Name error is also, I have given you a couple of examples, right? So you see name error here. One example is this is one, and this is also name. Sorry, if you don't have the variable within the scope, it is a name error, not value error. Sorry, my bad. So when you don't have a variable in the scope, but you are trying to access it, that results into name error. Value error is like where it is not able to convert the data, especially from one type to the desired data type. Like, say, for example, user enters string while the program expects an integer to be in or numeric string to be in. So, where it cannot convert this into integer, those results into value errors, right? So, value error, name error, index error. Index error, I have just given you an example of list, but this can also happen with tuple because you can also refer to data within a tuple using index. This may also happen with strings also because in individual strings you can also refer to each individual substring using index. So wherever index is possible, you may get this index error, right? This is about index errors. And I have also shown you what is key error. Key error happens on dictionaries, right? Because a dictionary is a key value pair. When you pass some key that's not present in that dictionary, in that key value pairs, in the list of in the set of key value pairs, then obviously you will be getting key error. This is related to dictionary. File not found error. Sorry. File not found error. File not found error also I have shown you where you try to open a file that is not present, then you will be getting file not found error. So these are different types of exceptions that we have discussed, right? And of course, there are other types of errors like there is a type error when you are trying to convert one type to other. That's not possible to convert one type into another, then it would be a type error. Okay, and there is an attribute error. Also I'll show you one more thing. Attribute error, if I have to explain attribute error, you need to have knowledge on classes. Since we did not cover classes yet, I am not going to touch that. So maybe you can just look at something like this. I have imported something and I am just printing something. It gives me some output. Don't really care about what it is. Okay, if you can use this path because it's from OS, you can look, you can check for exists and all that, right? So you can use this path dot something, you can exists or anything. If you want to know whether a file exists or not, you can just go with it. You can just ask for exists, right? Like this. You can call these methods inside this, right? Okay, all right. So this is all fine. But what if I try to import something like OSS? I don't know what that OSS module is. Okay, I'll just try to run this program. You see what you get? Module not found error. So module not found error, correct? So this is another type of error here. Okay, module not found error. Like this, in fact, though we call these are errors, these are all exceptions only. These are all exceptions only. So we need to have right plan, proper plan to deal with these exceptions. What happens if I don't handle the exceptions in my program? Whatever programs we have written so far, we did not really deal with exceptions. Still, we have been able to write hundreds of lines of code for different things. Perfectly fine. However, the main the key behavior of your program when exception happens is it cannot execute the rest of the statements in your code from the line where the exception happened. So it simply skips the rest of the statements in your at least it if unless it is the last statement which has resulted into exception at runtime in your code, you will be having some at least some statements that have not been executed at all. Make sense? Hence, there should be some proper handling of these exceptions. We need to take care of it at runtime, at development time only. We need to think of it carefully and we need to deal with it. So these are different types of exceptions, right? And these are common exceptions generally. While you work with Python code, you may come across some of these exceptions, all of these exceptions, if you have really worked with most of these things, right? These are quite common, very common Python exceptions. Okay, and you already seen what happens if the exception is not handled. That is also what I have just shown you with examples. Okay, what if exceptions are not handled? As I have given you examples, if I don't handle exception, what happens? These are all examples for that only. You won't get at least some statements executed in your program. They will be available in the program, but they won't be executed at all. So your program can abruptly terminate. So that is what happens if you don't handle the exceptions properly in your piece of code. It may result into some partial execution of your program. Okay. All right. Now, then what is an exception? How to deal with exceptions then? Okay. How to deal with exceptions? How to handle the exceptions? That's the next topic. Okay. How to handle the exceptions? Well, let me take this same example. I'm just going to uncomment this piece of code now. I will make use of this same code and show you how you can handle the exceptions. Here, let me first focus on this piece. Okay, and let me comment out this once again. All right. So what is a possible exception here? It's a value error, correct? Because user enters a non-numeric string and it cannot convert that non-numeric string into an integer. That is where you can get value error. Now, what you can do is, if you have to deal with it, if you have to, and also let me write down the last statement here also. I'll write one statement to print the last statement. Okay. All right. We'll once again run this piece of code for you just to understand the normal flow. And if you pass some numeric string, it works well. And I'm going to run this once again with bad data, meaning I'm just going to enter some string that results into value error as you have seen. And because of that value error, it did not get a chance to execute this piece of code and this piece of code because the exception happened here itself. It is unable to move ahead with rest of the things. It is unable to move ahead with these two statements, right? So what we are going to do now is we are going to have a mechanism of dealing with this exception by ourselves. How? This is a syntax. You should use try. Try is a keyword in Python. Once you type in try with colon, obviously a new scope will be started. New scope will be started. So whatever code that is risky, when I say risky, it is possible to get some exceptions from the piece of code. Any piece of code from which you can get an exception must be placed in a try block. Make sense? If you can put all your piece of code in try block, that is also fine, no problem, because anytime something abnormal happens, we can deal with it. So in general, if you write 1,000, generally we don't write thousands of lines of code in the same file or the same function. But even if you are dealing with some piece of code also, make sure that that piece of code has been properly handled from the exception handling point of view. Okay. What is that you need to do for that? Just place all your code within try block. If it is not all your code, at least the code which is risky to get some exceptions, mainly input from the user. Yes, there is no guarantee user enters the input in the format that we are expecting or the form in that we are expecting. The data type that I am expecting, the code is expecting is different, and the user can probably pass in different data type. So all those things are not under our control. So all such expressions or the statements can be placed within try. Next, you need to write a block called except. Okay, except this is a block which is responsible for handling the exceptions when they have occurred. Okay, so here I'll just simply say exception occurred. This is my own code, our own code, right? Okay. Did I handle the exception? Yes, I have handled the exception. What is the code that is looked for exception? This entire code will be traced for exception at runtime. All right. And what happens when exception really occurs? When exception really occurs, control comes here, and then what will happen? Let us see. There is a syntax error. I have corrected that. With syntax error, you cannot even start the execution of your program. Okay, I'll go with say happy path where I pass valid input and no issues. It has printed the statements afterwards that are afterwards. And then I'm going to run this once again into the edge. This time I give some bad input. It just gives you a message that exception occurred. So when exception occurred, when you can handle it by your own, okay, this is what you can do, right? This is what you can do. Okay, what happened now really? From where did the exception rise? The exception has been raised from line number this this line. Actually, I don't have the line numbers now to show you, but this is the line from which the exception happened. Because of this statement did not get executed. This statement did not get executed. Now what I'm going to do is I'm going to just show you something by placing these statements after except. Okay, assume that your piece of code, you have written the piece of code like this. Run this now. This time also I'll give some bad in. Okay, and you see this time it has printed exception occurred, and then it has given me a name error because I'm trying to print the name somewhere else. I'm trying to print the name somewhere else. So I print the age somewhere else, and within the scope it doesn't know what age is. So what I'll do, I'll just bring this back to, sorry, I'll just bring this back to this block only, try block only. Okay, because it makes more sense to print the age here only. Okay, now let me run this piece of code. There are three statements in my try block. There is one statement in accept block, and there is one statement which is completely independent of try and accept blocks. What happens now? Okay, you see here, I passed the age as 12. Works well. Sorry, this extra, this it was not able to convert this because it's not complete a numeric string. So exception occurred, but again, the statements in the program got executed. The statements that are within that block have been skipped, but the statements that are outside have been executed. Does it make sense? Look at this piece of code. Exception happened here. If exception happened here, it has gone to this accept block. It has executed this piece of code. After that, it has continued to execute the rest of the statements, following statements in the program. If you have not handled this exception, what would have had? What would have happened? It would have never got a chance to execute this piece of code. That is the difference between handling the exceptions and not handling exceptions. What the behavior of your program will completely change from the execution point of view. If you have handled the exception, okay, some piece of the code may not be executed, and whatever code that is available afterwards where you have handled the exception, that code will still get executed. Okay, so I'll just show you one thing. I did not handle the try and I don't have this at all. For example, what happens now? Tell me. I have these statements this way. And I have this statement. Now I'm going to run this again. Oh, sorry, where is it? Now I can comment on this one. Let it be, no problem. Okay. So now let me run this program now. Age is 12. All good. But exception occurred also has occurred, has been printed because it is not now controlled by any block, right? That's okay. Let me run this program for ABC or some bad input. You see, it did not print the rest of the statements. It did not execute the statements at all. That is what happens when an exception occurs and if it is not handled in the code that was written, right? This is a key difference, right? There are certain statements which are independent of the exception. They can be executed without any issue. Okay, these are nowhere related to the issue. These statements are nowhere related to the issue that has occurred or the exception that has been raised. However, they won't get executed. They won't get executed. I'm going to bring this back where I am handling the exception in my piece of code. What happens? Again, the same place there an exception happens. When the exception happens, control will be transferred to except block, and whatever is there in the except block that would be executed afterwards. Whatever the following statements are there, they will also get executed. That is how exception handling will help you to execute the rest of the statements in your program. I pass valid input, no worries. All the statements get executed except the except block statements. Now I run this once again. This time I pass wrong input, invalid input. See, it prints exception occurred, but however, it prints last statement. The only thing that I did not get is 34 because that 34 is kept in that is output statement. No, because of this you got 34. This statement is within the try block and exception happened in the previous line only, previous statement only. So control has come to accept block. It will never go back actually. Once the exception happens, it cannot go back and it continues with the rest of the statements. That is where you can see last statement also printed here. That is a key difference from the behavior point of view. What if you add this? What if you don't add? What if you handle exception in your piece of code? What if you don't handle? There would be drastic difference in the execution, the way the program is executed. So that is a difference. What if exception is not handled? Yes, program terminates abruptly. What if you handle the exception? At least the exception would be handled the way whatever the code you write in except block, that way the exception will be handled and the rest of the statements in your piece of code would be executed for sure. Okay, that is what the difference is. All right. Now, you have to remember this syntax really. Try, except. Try is a keyword, except is a keyword. So any risky code you put it in the try block, or any code that you think there could be a possibility of there is a possibility of getting some error, you put it in the try block. And the way you want to manage with that error when occurs, if occurs at all, that you have to put in the except block. All right. This is how you can go ahead and handle the exceptions. Now, I'm also going to show you how you can deal with divide by zero now this time, right? And if I don't have this exception handling, what is the error that I get in this situation? What I will get is I'll get value error. So you can explicitly mention like this, value error. If you write except value error, when the value error occurs, then this will be executed. So this except block is to deal with deal with the situation when value error occurs. If you write that way, if you don't write value error and if you just write except, that means it can deal with any kind of exception that happens during execution. Right now, I run this once again. I just give some input. You see, exception occurred. Last statement. That means this exception occurred has come from here. That means really it was value error actually. That's why it is able to come here. Now I'll just show you one more thing. Print something. Divide by zero. I am intentionally introducing the error now or exception now. This is quite possible to get an exception here, right? Now what happens? Okay, and I'll run this now. You see what happens. Age is I'll just give proper age. You see, we'll get division by zero error. At what line? This is on line number 23. Go and check what is there on line number 23. This is the line number 23. This is where the error has come. Okay. Did you get the message that exception occurred in the output? In the output, did you get the message exception occurred? You did not get. Why? Because you have handled only value error exception, but you did not handle zero division error. You did not handle zero division error. So if you just remove this, now if you run this program, the divide by zero error also will be handled by this same exception, because that exception is very generic exception. I'll show you. You pass some valid input, but you see exception occurred. From where did you get this message? You got this message from this block. That means when Python tried to execute this program, it got an exception. And since the piece of code which has resulted into an exception is in try block, it has gone to its corresponding except block and it has printed this message. After that, it has also continued with the rest of the statements in your program. So if you write except, just except, that is a very generic exception. You can also write more. You can also write more than one except blocks. See, I'm going to write now divide by zero error also. So here I would say what exception has occurred here? Value exception, value error or a value exception happened. Here I am just going to write down that divide by zero error exception has occurred. All right. You see, there is only one try block, but you have multiple except blocks. Quite possible because there could be different types of errors that can come from the same try block. So to deal with each of them independently, uniquely, you can write multiple except blocks. Now run this program. I just intentionally made some mistake while entering the age of the person. So it has occurred. You see, value exception occurred is what it says. That means this is coming from the first except block. Let me run this program once again. This time I give the age properly, but I got a divide by zero exception occurred. From where did I get this? I got this message from here. That means from here. That means this is the block that was hit by this piece of code when it raised an exception. So it has come to this and it has just given me this message in the output. This is how you can deal with exceptions and you can write multiple things. And if you want to deal with multiple exceptions by the same block, that is quite possible. I'm going to show that now. I just copy pasted the same code and I will just uncomment. Okay. Now I can probably deal with these two exceptions one after the other like this and put them in the braces. And I don't want to go with second exception now. Print something went wrong. Okay. So what is this, what is the meaning now, or what can happen now? For example, look at this piece of code, right? Your program will print the statement, first statement, and then comes here. Say for example, user has entered valid numeric string, then no problem with printing the age, converting into a integer and printing, no problem. But when it comes here, it gets divided by zero error. Which except block is responsible now to deal with zero division error? The same except block, because this except block is responsible for dealing with all this list of exceptions. So within that list, you do have the division by zero. So you'll be getting something went wrong. Next, you run the same program again. This time you have given a non-numeric string ABC, for example. It cannot be converted. So now this time the error comes from this line only. The exception will be raised by this line only. And what exception you would be will you be getting? It is value error, right? Obviously, that value error. Who is responsible for dealing with the value error? This guy. So in that case also you'll be getting something went wrong. Though it is not a specific description that you can get from the exception. However, it is quite possible to group a set of exceptions into single except block, and you can write the generic code over there. Okay. And last statement will anyways get executed now because it is irrelevant, or it is not related to any of. So first thing I will say, I just give intentionally wrong, but last statement has come and something went wrong also has come as in the output. Now I'll run the same program again. I'll just enter the age properly, but you'll be getting something went wrong. Who is responsible for this something went wrong? The division by zero, right? The division by zero has resulted into executing this piece of code now, because this results into zero division. This is where you got that. Make sense? All right. This is how you can write individual except blocks for each type of possible exception that you can anticipate, or if you are not so peculiar about, I don't that those specific exceptions, but you just need an indication that some exception happened, then you can club multiple exceptions together and write down just one except block, and you can deal with it. So this is how you can handle the exceptions. Okay, these are different ways to deal with exceptions. Whichever is convenient for you in the given context, you just go with it. All right, let's move on to the next topic. The other thing is, okay, let me just get rid of, okay, he can still let it be. What you can do is, I'll just copy this. Okay. Other way of dealing with exceptions. Okay, and don't need this now. Let be anyways. Okay, look at this now. This is a piece of active code, and I will just comment out this. Hmm. This is a piece of code, and you can probably capture an exception as an object. Again, what is an object? That would be covered in our next live session, because I'm going to talk about classes and objects in Python in the next session. But for now, I assume that object is some kind of a variable now. Okay. So whenever there is any situation of getting an exception from the piece of code that you have already written, what you can do is you can just write except, and if you want to access that entire exception object, you can write exception as some variable you give. Generally, I use E because it stands for exception. And now you can directly print E. I'm printing the entire object. You see the difference. It's the same piece of code in the try block, but what I have asked is when an exception occurs, any exception basically, when an exception occurs, get that entire exception object into E is what I'm asking. And I'm trying to print the E value. Let us see what happens now. Let me try with divide by zero. So I should do the age properly. You see, division by zero is what has been printed now. Look at the piece of code. Did I anywhere write a division by zero within this piece of code? No, right? And let me bring in last one also here so that you will understand the flow of execution. I'm running this again, right? And here's just something. Okay. 45 has come, divided by 0 has come, last statement has come. Where did this division by 0 from? If you look at division by 0, this first of all, this is a statement responsible for that bad operation. But when this has occurred, what happens? That entire exception has been copied to E. And when you have printed E, that print E has really printed this message. What is that message? Division by 0. After that, what happens? The rest of the statements get executed properly. So it just has given last statement. Makes sense. So this is how you can, and here E is called object of exception. It's an exception object. Okay. You have copied the exception object into a variable E and you can make use of it. You have when you print E, you will just get more details. And you can also probably type type of E. What is the type of E you're asking here? And I'll run this once again. Is 45. And you see division by zero error. Okay. And during handling exception, another exception also happened. Interestingly, you see this, there is another error. Okay. I had given TTP instead of type, which resulted into name error because it doesn't know what is TTP. It can only know, it can understand type. Python, there is something called type in Python, but not TTE. So, and this is a very good example for you to show or confirm that piece of code that is in the accept block, it won't, it has been examined or checked for errors only at runtime. It is not syntax error, right? This is not a syntax error. So while execution, it came to know that oh, I did not find anything by name TTP. All right, now the age is something, and then you see the type is value error. Type I have printed the type now. The type is value error. I have printed the type of E, type of that exception. It is value error, and after that also has printed last statement. Makes sense. So this is how you can grab the entire exception object into some variable and you can make use of that variable. Either you can print that entire variable or you can find the type of that entire variable. If you know the type of that entire variable, you can write some conditions also. If type is integer, do something. If type is string, do something. Sorry, if type is value error, do something. If type is key error, do something else. Like that, you can categorize this block of code in the except if you have that exception object into different execution paths and you can deal with them, you can address them differently based on your need. All right. So that is about capturing the exception object. All that you need to do is you need to write this extra piece. Instead of exception name, exception class name like value error or something, you just write something like this exception as some variable name. All right, that is to capture the entire exception. Okay. The next one is else block. What is this else block? How can we use else block with exception handling? Let me show you. What if I put this in else block? This entire, sorry, and I'll add one more statement here, okay? Or let me call this one only as last statement. I would say this is else block or I am in else block. Okay? This is my piece of code. And assume that this, I'm just commenting out this. Okay. I assume that this line is not there. Okay. Before I go any further, what I will do is just write down what we have covered so far. Okay. Different ways of handling exceptions. Yeah. That's what we have discussed. In how many different ways we can handle the exceptions. Similarly, how to capture exception object. Yeah, that's what we have discussed. And now we are going to talk about else block. What is else block? Look at the piece of code now. Mm. If you look at the piece of code, you have first statement and then a statement to read the age and then also print the age. Simple three statements. And there is an exception and assume that this is a very generic exception now. This is very, it can deal with any type of exception that has been raised at the runtime. And you have else. Else can be used with if. It can also be used in exception handling this way. And we have printed I am in else block just to indicate where we are and when does this execute. When does this else block execute? I have just printed like I have just added some statement like this. And then last statement. Now let me run this program. First I'll go with happy path where I'll be entering some valid age and it has come to else block. And it has also printed last statement. Okay. In this situation, did the exception occur or not? First of all, exception did not occur because you have given proper input where which can be converted to an integer. And okay, instead of type E, I should say exception occurred is what I have just printed. Okay. So let me run this program once again just to prove that the exception code did not get executed. See, it did not say that exception occurred, but it said I am in else block. What does it mean? What is the situation now in the previous execution? In the previous execution, exception did not occur. So it has printed the age. After that, where did it go? It has come to else block. After that, it has also printed the last statement. That is what you see here. Okay, sorry. Okay, first statement has come. Then it has prompted the prompted for age input. Whatever user has entered, it was able to interpret it properly as an integer and it has printed it and then it has come to else as well. So this is a situation where exception did not happen. Still the code in the else block got executed. I'm going to run this one more time to create an exception intentionally. I'm going to make an exception here. Yes, there is an exception. In this case, exception occurred message has come, but I did not get the message that I am in else block. And last statement anyways has got executed. What does this mean now? Look, when an exception happens, the code in the except block will be executed in this scenario. When the exception did not happen, the code in the else block would be executed. That is how you can use else with exception handling. Except block is there always to handle the exception if at all it occurs. Else block is there to execute some piece of code if the exception did not happen. So maybe I can write some message like went well or something. All went well or something, right? Now probably it makes more sense for you to understand this piece of code and execution flow. I guess I haven't read code 45. What happens? Okay, it read 45. It has also printed it back. Okay, and then it did not go to exception block because no exception was raised, and it has printed only what? It has come to else block, and it said all went well, and it has printed log statement. That's what you see here. Okay, compare this. There is no exception, so it has printed age, and then it did not go to accept block, but it has gone to else block. It has printed all went well. After that, it has printed last statement. I'm going to run this once again. This time I'm giving some invalid input. Okay, and you see you got an exception here, and it did not print age because it could not. And then it comes to exception block and has printed exception occurred. And when exception has occurred, it doesn't go to this block. Right? It has gone to accept block, so it cannot get into else block. If it did not get into else exception block, then it can get into it will get into else. That is the behavior of try except else. And last statement will always be executed because it's nowhere within these blocks. It is independent statement altogether. So this is the difference. When you use else statement, the body within the else will be executed in the exception when the exception did not happen. If the exception happened, the body in the exception block is executed and the body in the else block is ignored. This is how else would be working. Okay. You also have one more thing, which is finally block. In the same piece of code, if I just bring this back, what would happen? Can you guess? Look at this piece of code first of all. Okay. First statement over. No problem. It will execute. No issue. Enter the age. Age has given a proper age only has given assume. I given proper age 25 or something. Okay, age becomes 25. It prints to 25. After that, it comes to this. It comes to this statement, and it will get divide by zero error. Then what happens? Because it is an exception, it gets to accept block. And in this case, it will never execute else block. Never. Because when you run this piece of code, always this piece of code would be executed. When I say always, assuming that as in all the times where age has been given as proper value, this would be executed. Or if the age was not given proper, exception would be raised from here. The age is has been given proper, exception will be raised from here. That means this piece of code somehow it will raise an exception, no doubt about that. Either a value error it would raise, or it would write a zero divide by zero error exception, right? So whichever exception happens, it would get into accept block. That means in this case, else block will never get executed if you have this piece of code with you. So run this. I give proper age. Exception occurred last statement. This exception occurred has come from exception block. I run this once again. This time I give bad data intentionally. See, it has never got into else block. You would have gone into else block, you would have got that message, a different message. What is that? All went well. But this all went well has never come. In both cases where the exception did not happen and exception happened, right? So in this case, exception happens all the time, no? That's why definitely it gets into accept block and it will never get into else. This is how you need to understand this. And next one is finally. What is finally? You can just add to this actually. Uh-huh. You can add one more finally block here. And you can say I am in finally. Okay. Now save this and run this. So what happens now? Tell me. Assume that age was given properly, 25 or something. Other 25 is printed. Here you will get an exception. It comes to exception block. Else won't get executed because it has got into accept block. And still it gets into finally block and it will also print I am in finally. Let me run this program for you. Age is something valid one. Exception occurred. Yes, this is an zero division exception, but it has come to I am in finally and it has also printed last statement. Makes sense, right? Now, if I give some bad input like this, then also the same story because this time the exception is different. That's all. Earlier it was divided by zero exception, but here it is value error exception. If you print the details, you get to know. But there is some exception definitely, so it doesn't get into else block. But remember, finally block will always get executed, whether the exception is raised or not, irrespective of it fact. If irrespective of the fact, the finally block will always get executed. So this is helpful when you want to make some cleanup activities, like you want to shut down the database, you want to get the disconnect from the database in your projects, or you want to close something that was already open, or that you want to properly handle something that you have been used in your program so far, but you are about to quit basically, and you want to handle with it. You don't want it further and you want to deal with it properly. Then you have to use finally block, and within the finally block, you write that whatever code you want to deal with. That would help you with dealing with all those situations. So every block is important. Try all the code that is risky, except all the code that it will handle when exception happens. Else code will be executed. The code under else will be executed if and only if there is no exception happened. Finally gets executed always, and that's why it is ideal for freeing up or cleanup activities in your projects. All right. So what if an exception occurs in try block in this example where you have all the four? Try, you have except, you have else, you have finally. What would be the code flow if the exception happens? It gets into exception block. It doesn't get into else, but it gets into finally block. It also executes this statement. What if an exception occurs? If an exception occurs, control will go into except block and else will not be executed and finally will be executed. And last statement will also get executed. What if exception did not occur? The body in the else block will be executed and the body in finally will also be executed and last statement would be executed. That is a key difference, and how you can keep on building your logic using these different methods of handling the exceptions. All right, let's move on to the next topic now. Okay, which is nested try blocks. Okay, nested try blocks. What are nested try blocks? Nesting. Nesting means using try except within try except again. Okay, for example, I'm going to write one more try here and say a is 0 and I just write it down as, let it be. I'll just change this. I write one more except. Print exception in inner block, and this is exception in outer block. Let's forget about this thing for now, and I still have the last statement. Hmm. Look at the code and assume that the code is this way. First statement always gets printed, and if user has entered the age properly, it prints it, and then it executes this piece of code. And definitely exception happens here. So, but which except block? Because you have two except blocks, and right now you are in inner try except block. Who will deal with this? This or this? The inner block, obviously, because you are in the inner block when the exception happened. So the inner exception block will be taking care of that. So when you have 5 divided by 0, obviously the exception will be handled by this. So you should get exception in inner block. And there is no any exception in outer block. Hence, you won't get this statement executed, but you will be seeing last statement. So the output here would be if you have given proper age, you will be getting exception in inner block. First statement you will get in the output. Entry age you will be seeing. Exception in inner block you can see, and last statement is what you can see. Let us run this. Age is valid. Okay, you see exception in inner block and last statement has come. I run the same program once again. This time I will intentionally make mistake in input and entering the input. You see exception in outer block and the last statement. What happens now is here only you got an exception, but this exception is in the outer block. So the outer try related except, where is it? It is here. This is what has to take care of it. So from here directly from this line, control directly comes to this line and it executes it. And as you know, once the exception happens, the rest of the statements in the program will be executed, but it will not go back to the place where it has stopped. So only the following statements get executed, right? So this entire thing will be skipped. That means this piece of code will never get executed in that situation. Okay, because you got an error here itself, exception here itself. So it will directly come to its corresponding except, and it will print this and it will go to last statement. So if you run this program, you can see first statement coming out, enter the age coming out, you give some invalid input, then it comes here, exception in outer block will be coming, last statement will be coming. Let me run this. Yes, exception in outer block and last statement. So this is how you can use nested blocks, nested try blocks, and you can control how you want to deal with exceptions, right? All right. Next, the very interesting thing where you can raise your own exceptions. And before going there, first of all, how can we raise some existing exceptions only? I'm going to talk about raising exceptions. So this is nested try blocks. Okay. How do you raise exceptions? Again, I will just comment on this code just for your future use. And here, yeah, how do you raise exceptions? Yeah, to raise exceptions on your own, let's give, I'll just again take the same age example. Okay, here you can check. Of course, you can check for type and all, but I just want to really check if the age is less than 18. If age is less than 18, okay, I can raise an exception using raise keyword. Raise is a keyword in Python, RAISE, raise, right? I would like to, what exception you want to raise? You can raise any exception because it is all under your control. Raise value error exception. And when you are raising any exception, you have to write like this, and you can pass any input also. You can say age must be at least 18, something like this. That's all. You see, now exception will be raised, and you are raising the exception. So you run this age, you give something like 13. You see, value error. Age must be at least 18. So you have customized the value error exception now. Yes or no? Value error, and whatever you have given, that message has come. Look at this. You have written age is equal to this. So it has prompted you to enter the age. You have entered some age 13. 13 less than 18 is true. So then, because this condition is true, it has got into this if block, and it has raised an exception. Which what type? Value error. That's why you see value error type of exception. And it has printed that age must be greater than 18, whatever you have given here. Right? This is how you can raise your exception. But remember, you can raise this exception also really, right? Because it's all under your control now, right? Let me run this. Age is some 10. You see, zero division error exception has been raised, and with the message is this. But always try to raise the exceptions which are very much valid in the given context. Since you have the freedom of raising any exception, don't just mix up the things. This is very much related to the value of the input. It should be greater than 18 or equal to 18. So make just to make it as value error only. There is no system in Python which will really check, given the given context, whatever exception you are raising is valid or not. That's why you have the full freedom of raising any kind of exception in any situation. But it makes sense to have valid exception raised under the given context, right? Now I'm going to run the same program once again. This time I'm giving 20. All good, no problem. There is no exception at all. All went well. To prove that all went well, I'll just put this last statement also because I'm not printing anything. No, now you'll understand. Run this. All right. Now age is something greater than 18. You get last statement. That means exception did not happen in this case. Exception did not occur in this case. This is how you can raise your own exceptions. Raise and the string to your exception can be customized. You can give whatever name you want, whatever string you want, and value error is what I have raised here. It is 0 divided by 0. If you don't like that message that automatically comes, you can customize, you can just raise an exception of your own, and you can pass whatever message that you want to see when that exception is raised. So this is all about how you can raise exceptions on your own, raising exceptions on your own. Okay. And the other one, the last one is how to raise, how to create custom exceptions. What do you mean by custom exceptions? So here for this, when the age is less than 18, I want to create an exception. and that exception is not related to some system exception like not value error or not divided by zero error, or it is even not an index error, not Python inbuilt exceptions those are, but I want to create my own exception. For that, what you need to do is, okay, I don't want to disturb this piece, of keep this as it is. I'll just copy paste and explain this. Okay. Yes. I want to create my own exception. For that, you need to just write class and say age limit error. This is some new exception I'm introducing to the system now. And the syntax is this. Sorry, and just write pass here. I'll talk about what is pass in the next session, in the next live session, and what's a class also, because the next session is primarily focused upon object-oriented programming features. So then you will understand the actual meaning of the code that I'm writing now. But for now, just understand the syntax. Okay. Okay. User has entered this. If age is less than 18, what you can raise is instead of value error, you can raise this type of error. And message up to you. You can put the same message. Okay. Let me run this. All right. I'm going to give 13. And you see what is error now you got. It's not value error, it is not g divided by zero error, but it is your custom exception. It is age limit error, and message whatever you give that will that you can see here. This is how you can create your own custom classes. You can create some classes and you can use them for raising the exceptions this way. But remember, this exception is very important that you write within brackets. All the meaning of it and all will be explained in next session. However, but this is how you have to write piece of code for that. You can use any name here, and but the same name you have to use when you are raising the exception in your piece of code. That is how you can deal with exceptions. All right. So I hope I have covered everything. Let me go back to the slide and let us quickly go through content. Okay, the very basic syntax of exception handling is try, and you write some risky code within the block of try, and in the except block, you write some code that can handle that except. Makes sense. All right, and yeah, this is a syntax. And what if you don't handle exception, right? Say, for example, you have written one statement like this. There is no exception handling at all. What happens? Program will terminate and any subsequent statements in your program won't get executed. Abruptly, program will terminate. If you want to deal with exception handling for this situation, put the risky code or any code that you write in try block in the except block, handle it. Avoid divide by zero, whatever. It's a custom message that you, okay? This is how you can deal with exception, first of all. And if you want to deal with specific type of exception, you can mention that it's specific type. Here it is zero division error, so it will be handled by this case. The next one, if you have some input like this, you are reading the age, and if you without exception handling, that is how the code would be. But if you want to deal with exception handling, this is a value error actually, right? It's not a division by zero error. Like if user enters non-numeric string, you'll be getting a value error. So this block of code will deal with value errors. So the message comes now out as enter numerics only, because when you are asking for age, it can be only numerics. That's why. And look at this code without any exception handling. So you are reading two numbers. One is stored in F and the second one is stored in S. Okay, enter first number is a prompt, enter second number is a second prompt. And if you just print F by S, Okay, there can be multiple errors here, right? Multiple possible errors. That is what you need to think and put them in exception blocks. Try blocks and exceptions can be handled carefully. What are possible errors? Number one, user input can be wrong, which it need not be an integer. Second thing, what if the second number is zero? Because you're using division here, no? So second number cannot be zero. So all that I'm doing is I'm just putting this in the try block and I'm writing different exception blocks. In case user gives me incompatible input, then this block will be dealing with it, saying that enter numerics only. If the input is if the input is 0 for yes, then zero division error will come while executing statement number 4 and you will be getting this exception that divisor cannot be 0. Makes sense? This is how you can have one try block and you can have multiple except blocks implemented, right? And if you, this is how you can club the multiple exceptions into single and write generic exception code. Invalid input, simple. Make sense? Whether it is a value error, whether it is a zero division error, ultimately I'm calling it as invalid input, and this is how I can club those things together. Okay, and the exception object, this is basically I have just shown you where you can use except and you can read exception as into E and you can print the exception into that, right? So this is a piece of code for that, right? You receive the entire exception object and you can print that exception object, or you can, if you want to know the type of it, you can also print the type of exception object. Okay, this is all what I have already covered. Try, except, and else, right? How to use else and when does the code execute? Code to run if no exception happens, right? If the exception happens, the code in the except will be executed. If the exception did not happen, the code in the else block would be executed. And here is an example again. You read two inputs and you divide the first one with the second. And if you have try and if you also have except, what happens is, sorry, sorry, 1 second. Yeah. If you have exception, then the body of except will be executed. If there is no exception at all generated during runtime, then the body of else will be executed. So I have just kept a message like division successful. If there is an exception, it says invalid. All right. The next one is to use finally. You can directly use finally with a try. So you can write some risky code in the try block. In the finally block, you can write code which will anyways execute, whether there is an exception, whether there is no exception. But I want to execute this piece of code. Then you can put it in finally. A simple example: you read two inputs, and you again divide the first one with the second. Okay, if this end of the program statement gets executed in any case, whether the exception has come or not doesn't matter, right? That's why I said, right, any cleanup activities can be taken care within finally block when you're dealing with exceptions. And this is all for try, except, else, and finally. That is what I have also covered. Finally, right, all the four. Try, you have try block, you have accept block, you have else block, you have finally block, you have example. You have again division by 0. It has its own exception block, and if exception does not occur, what to do, that you put in else, and the piece of code that you anyways want to execute, whether or not the exception happened, you can put it in finally block, right? And nested exception blocks is what I have already covered again, right? Try this, try except on line number from line number 3 to 6, that is inner exception block, inner try except block, and this is outer one. And this is how you can write. You can. This is an example of try except with nesting. All right. The next one is how to raise an exception. This is also what I have already shown you just now. You can raise the already existing exception in Python, but you can customize the input string. Or if you want to use user-defined exception, you have to first define a class. Okay, and then you can write the pass in the body of the class, and then you can just raise an exception of that invalid is error class. All right, this brings us to the end of the today's session. Before we conclude, for those who have joined late, I would like to introduce our website. This is our website, technolearnit.com. You can visit our website and you can get in touch with us in either of these means. And we are also available on multiple social media platforms. I would highly encourage you guys to um, subscribe to us on these social media platforms and encourage us. Similarly, in the resources page, you will be having access to all the study material or the material that has been used in all the sessions that we have conducted so far. These are all the links for them. You can download these for free and make use of them and become good at programming. The same page also contains the information about the next live session, date and time. Hence, I would strongly encourage you to keep an eye on this page and be up to date with the latest information about our live sessions. The other thing that I would like to introduce is the Technolearnit YouTube channel. If you have not subscribed yet, I would encourage you to subscribe to this channel so that you will be getting updates. And the most importantly, you will be getting quizzes on a daily basis, and these quizzes will be helping you to guess the answer for a given question of the day. And if you watch this quiz till end, it is just less than half minute quiz, okay? And you will be getting an opportunity to also validate your guess, okay? And being in touch with these daily quizzes would help you to crack your written tests or any kind of programming interviews easily. Hence, I would strongly suggest you to subscribe to this Technolearnit YouTube channel and get up to date information. With that said, we hit the end of the session 17, and that's all for this session. Take care. Thank you.